Why does this seemingly perfect planet make scientists increasingly uneasy? It has no shortage of sunlight, warmth, and could even harbor liquid water, fulfilling nearly all our fantasies of a second Earth. But the more we study it, the stranger it becomes. With a radius about 2.4 times that of Earth, its size exceeds the theoretical limit for a rocky planet, yet it isn't large enough to be a gas giant. Its mass and surface composition remain a mystery to this day. The planet sits squarely in what's known as the Fulton Gap, a planetary radius range where planets are rarely found, a location where, according to our current models, a planet shouldn't stably exist. Our own solar system has no such in-between planet. Even more bizarre, its orbit is a nearly perfect circle, with almost no eccentricity and no visible gravitational disturbances. The entire planetary system is unusually clean, with no moons or other known planets. Every detail appears so meticulously designed that it feels less like a product of natural chance and more like the result of intelligent tuning. This is Kepler-22b, a planet that shouldn't exist, yet has become one of the most scrutinized objects in astronomy. Today we're not just giving you the stats, we are deconstructing its anomalies to uncover the cosmic secrets it might hold. A miraculous discovery. The discovery of Kepler-22b was itself an astronomical miracle, like finding a needle in a cosmic haystack. In 2009, NASA launched the Kepler Space Telescope. Its mission wasn't to take beautiful photos of nebulae, but to act as a patient sentinel, staring at over 150,000 stars in the Milky Way, waiting for the faintest dips in their brightness. This is called the transit method. When a planet passes in front of its star, it blocks a tiny fraction of its light. It sounds simple, but in practice, it's incredibly difficult. Imagine lighting a candle 100 kilometers away and trying to detect the momentary dimming caused by a mosquito flying past the flame. Kepler's job was to capture brightness changes as small as 0.01 to rule out other phenomena. The same dip in brightness had to be observed 3 times in a row to confirm a planet's presence. In December 2011, after 2.5 years of analysis and verification, NASA officially confirmed the existence of Kepler-22b. It was the first exoplanet humanity had ever confirmed within the habitable zone of a sun-like star. This discovery marked the dawn of a new era in the search for life in the universe, perfectly unnatural. Located about 600 light-years from Earth, Kepler-22b orbits a G-type star, very similar to our Sun. Its year lasts about 290 Earth days, and its orbital radius is about 85% of Earth's. This places it squarely in the Goldilocks sweet spot of its star's habitable zone. If it has an Earth-like atmosphere, its average surface temperature could be a comfortable 22 degrees Celsius, 72 Fahrenheit, a perfect spring planet. But the more perfect it seems, the more unnatural it feels. The 4 great mysteries. Scientists have proposed 4 main hypotheses about its true nature, but none can fully explain all its oddities. A super-Earth? It could be a massive rocky planet with a thick atmosphere. The problem is, a thicker atmosphere would create a runaway greenhouse effect, potentially turning its surface into a high-pressure cooker like Venus. But if the atmosphere isn't thick enough, its large size can't be explained. Simulations always get stuck between too hot and too cold, as if an unseen hand has precisely calibrated its parameters. An ocean planet. It might be a water world, completely covered by a global ocean hundreds of kilometers deep. While this sounds idyllic, a lack of land means no efficient geological activity to cycle nutrients. Life, if it exists, might be forever stuck in a primitive microbial state, unable to evolve into a complex biosphere. A mini Neptune? It could also be a small gas planet with a rocky core and a gaseous outer shell. However, such planets typically form much farther from their star. If it formed elsewhere, what force dragged it so precisely into its current perfect orbit and kept it stable? A hybrid planet. Another possibility is a complex multi-layered body with a rocky core, a water layer, and an atmosphere. While theoretically possible, The conditions required for such a planet to form are incredibly specific and almost impossible to replicate in known planetary evolution models. Every theory leads back to the same dead end. This forces us to ask a deeper question. What if our planetary models are wrong? An invitation or a warning? Thico. Scientists first suspected the data, but repeated verifications ruled out all errors and interference. The conclusion was unshakable. Kepler-22b is real. Some suggested it might have lost its planetary siblings in a cosmic catastrophe, but the system is pristine with no debris or signs of gravitational disturbance. So why does it exist? Why does it hit every single optimal parameter with such precision? This string of just rights. Once is a coincidence, twice is luck. But when all these perfect conditions converge on a single planet, it demands deeper consideration. We can't recklessly claim it was manufactured, but when a planet's features all look like a finely tuned standard sample, we are justified in asking a bold question. Is its existence a hint, an invitation, or is it merely a specimen in a far grander cosmic experiment? Kepler-22b itself may never give us the answers, but it forces us to reconsider the laws of the universe and our own place within it. If the cosmos truly has left behind such a perfect model planet, what is it trying to tell us?